Welcome back to my next video, guys. In this video we are going to learn about Coulomb's law and its various functions. Please take a copy and a pen with you to note down the following details with me. So first of all, let's define Coulomb's law. Coulomb's law states that when two stationary objects repel or attract each other with a force which is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So, if we take two charges q1 and q2 which are situated at a distance r apart, then the force acting between them will be given as F proportional to q1 q2 divided by r square. First carefully write down the definition and then we will share the equation with you all. To understand this more carefully, let us draw a diagram where q1 is the first point of the charge and q2 is the second point of the charge, and r will be the distance between them. Now let's come to the equation where F is proportional to q1 q2 divided by r square, where q1 q2 are the charges. We can also write this equation as F is equals to k q1 q2 by r square, where k is the proportionality constant. K is the proportionality constant which depends upon the medium in which the charges are placed and the units used for charges, distance and force. If the unit of force is Newton, unit of distance is meter, unit of charge is Coulomb, and both the charges are situated in vacuum or air, then the experimental value of K comes to 9.0 into 10 to the power of 9 nm square C by C square. Therefore, we can write the equation as F is equals to 9.0 into 10 to the power of 9 q1 q2 by r square Newton, where 1 microcoulomb equals to 10 to the power of minus 6 coulombs. If the charges are placed in vacuum or air, then the proportionality constant K in equation 1 will be written as 1 divided by 4 pi epsilon naught or epsilon 0. So we can write the final formula of Coulomb's law as F equals to 1 by 4 pi epsilon naught q1 q2 divided by r square Newton. Please remember this formula. This will be very helpful regarding the numericals. Now, what is epsilon naught? We can write this as epsilon 0, which is also known as permittivity of free space. By this, we can find the original value and unit of epsilon naught. We know that 1 divided by 4 by epsilon naught equals to 9.0 into 10 to the power of 9 nm square by c square. Therefore, epsilon naught equals to 1 by 4 pi into 9.0 into 10 to the power of 9 c cube divided by nm square, which will result to 1 divided by 4 into 10 to the power of 9 into 3.414 into 9.0 c square by nm square, which will result to 8.85 into 10 to the power of minus 12 c square divided by nm square. Now let's move on to the dimensions of epsilon naught. To find out the dimension of epsilon naught, we have epsilon naught equals to 1 by 4 pi q1 q2 divided by fr square. Therefore, dimension of epsilon naught will be a square t square ml t to the power of 2 l to the power of 2 square, which will result to m to the power of minus 1 l to the power of minus 3 t to the power of 4 and a to the power of 2. When the surrounding medium is not vacuum but some insulating material such as gas, wax and paper and oil, then the force between the charges is given as F equals to 1 by 4 pi epsilon q1 q2 divided by r square, where epsilon is known as absolute permeability. For air, the absolute permeability is slightly higher than epsilon naught, so it is almost equal. For other material, epsilon equals to k epsilon naught, where k is a dimensionless constant, also known as the dielectric constant or relative permittivity or specific inductive capacity of the material, and the material is called as dielectric. Now let us move on to the Coulomb's law in vector form. To understand this more greatly and carefully, let's draw this diagram where A and B are the point charges and O is the connector between them. Let the charge A and B be q1 and q2, and the vectors OA will be r12 and OB will be r21. For q1 q2 greater than 0, where AB will be vector r2 minus r1 equals to vector r21, and let BA vector will be r1 vector minus r2 vector equals to vector r12. The distance between the charges will be decided by AB equals to mod r2 minus r1 equals to r1 minus r2 equals to r. Let's assume this as r. Then the force acting, the Coulomb force acting on charge q1 due to charge q2 will be vector f12 equals to 1 by 4 pi epsilon naught q1 q2 divided by r square, unit vector r12, where unit vector r2 is the unit vector along vector BA. Then vector r2 will be written as r vector r12 divided by mod vector r12, which will result to vector r12 divided by r. Thus we can say vector f12 will be written as 1 divided by 4 pi epsilon naught q1 q2 by r cube r12. Similarly, the force acting on charge 2 due to charge 1 will be vector force 12 will be written as 1 divided by 4 pi epsilon naught q1 q2 divided by r cube vector r21. Let's now move on to the importance of Coulomb's law in vector form. We can write unit vector r21 equals to minus unit vector 12. It gives the, since the unit vector is in opposite direction, it follows the negative pattern. Again, we can express the forces F21 and F12 act oppositely along the line joining the two charges Q1 and Q2. That is the electrostatic force, which means it is a central force. If you haven't subscribed our channel, please do subscribe, like if you liked the video, and share with others. And again, thanks for watching.